How's it going, everyone? In today's video, I wanted to talk about indexing strings in Python, because all these years I thought it was simple, but it turns out I was wrong. There's more to it than meets the eye. See, I always thought that Python did some magic behind the scenes, so we didn't have to worry about how we indexed a string to get data back. If we had some text of type string, and that was equal to Bob, to get a certain character back, we would just print the text at that index, such as at the index of 0, and that would give us back the character B. So I thought that everything was treated as a single character, but the reality is I never had to deal with complex character types, and I couldn't have been more wrong. Now this is something I found out after writing some code in Rust on my other channel, Rustfully, and in case you're curious about my other channel, I've put a link in the description. Be sure to check it out. If you enjoy my teaching style and want to learn a different language, I absolutely recommend Rust. Anyway, continuing with the topic of the video. The term character in programming is a huge abstraction and can mean many things. When a programmer says character without any context, they could mean a regular character, or they could mean a byte, a code point, a grapheme, or even a grapheme cluster. In CPython, which is the official and most widely used implementation of Python, and probably also the one you're using if you downloaded Python from python.org, string data is stored as code points. And a code point is the number that's assigned to each character in Unicode. Take a look at these characters, for example. Here we have or, a, and the smiley face emoji. Now what we're going to do here is loop through them. So for C in characters, or in other words, for character in characters, we're going to grab the code point of each character. And that's going to be an integer, and we can grab the code point by using the built-in odd function. This retrieves the Unicode code point value of the given character. Next, we're going to print the f string of the code point, which will be u plus the actual code point, and that's going to give us back the following grapheme, which we can get back by using the character built-in function with the code point. So odd and character essentially go hand in hand because you can use either one to convert one into the other and vice versa. Now just to briefly explain what a code point is and what a grapheme is, the code point is the number that's assigned to each Unicode value in Unicode. So it's this part here. I mean, usually you have u plus some number, and that number is the code point. A grapheme, on the other hand, is what we typically think of as a single readable character, like or, a, or even this smiley face. Now when we run this, what we're going to get back is the code point and the grapheme, which would look nicer with a colon. And code points are usually written in hexadecimal. So if you want to see what that looks like, type in :04x, and the next time you run this, you're going to get it back in hexadecimal format. Anyway, now that we know a little about code points and graphemes, let's move on to the part I wanted to talk about. There are some special graphemes known as grapheme clusters, which may be composed of multiple code points to form a single visual unit. And that's what we'd consider to be a character. For our next example, we're going to look at these characters. And here we have two graphemes and two grapheme clusters. But what's the difference and why does it matter? Well, it matters with indexing, because grapheme clusters are composed of multiple code points. This means that when we try to access them, we won't get the character we were expecting back as a result. These characters compose the following Hindi word, namaste, written in Devanagari script. And I apologize deeply for my pronunciation, but what you'll notice when we try to index this word is that it's not going to be treated as 4 characters. And this is because it contains diacritics that have their very own code points. And diacritics are just a fancy word for the signs, such as accents, you see on letters that indicate a different pronunciation of the same letter. For example, in Italian we have e with this small accent on top, and in Scandinavian, there's the letter or with the ring on top. Those are diacritics. So these two grapheme clusters contain diacritics, which means that once we print the length of this greeting, what we're going to get back is 6, not 4. Even if there are 4 characters, the diacritics count as their very own code points. And this can cause some confusion, because if we try to index this string at the index of 3, what we're going to get back is a diacritic, which means nothing on its own. Also, the reason we see nothing as an output here is because of a limitation in my Mac terminal that does not fully support these characters and cannot render them properly. We're still getting the output, it's just that my terminal does not render them. And we can verify that just by getting back the code points for the greeting at that index, and you'll see that it will give us back that code point. So the character is there, it does exist. We just can't see it. So what we're going to do instead is move on to idle, where it renders this information properly so we can actually see it. So here I'm going to enter my greeting, and I accidentally have a space in front, so I'm just going to fix that. But now I have my greeting entered. Next I'm going to type in for character in greeting print C. And what we're going to get back are these 6 characters. And this consists of 4 graphemes and 2 combining marks. The funny space you see is just the placeholder spot, because again, on its own, these diacritics just don't make sense. They just don't work on their own. Now, with that being kept into consideration, we can start to index our greeting at the index of 2. And what we're going to get back is this character over here. Now, at the index of 3, it's going to return the combining mark at the index of 3. And that's something that didn't render properly in our regular terminal. So if you're just running a normal Python script and you don't see anything as an output, I mean, if we remove odd, it's not because it's not there, but because your console or terminal failed to render it properly. But as you can see, it makes sense now why we're not getting the full character back. Because it turns out it's actually a grapheme cluster, which means to get it back, we're going to have to use slice notation, just like in Rust. So here we'll type in from the index of 2 to 4, and that's going to give us the full character back, the full grapheme cluster. So as you can see, there's more to it than meets the eye. When the characters are composed of multiple code points, we get back results that we might not have been prepared for, such as only a piece of the character, when we wanted to grab the whole thing. And again, I made this video because I thought Python simplified this for us by just giving us back the entire grapheme cluster at the specified index. But it's not that simple in the end. All I know is that the more I learn that I know nothing. Anyway, if you want to learn more about programming, I really encourage you to follow me on my Rust channel. We tackle a lot of cool topics there that will probably influence the way you write code in Python as well. So once again, I've left a link in the description box down below in case you're curious to see what Rust looks like, or you're just curious on picking up a different language and you enjoy my teaching style. Feel free to check that out. But otherwise, as always, thanks for watching, and I'll see you in the next video.